Hey guys, and welcome back to another video. And in this video I want to be talking about how to select appropriate image data and where do you actually get this data from. So in order to use ENVI, first we need to get layers and stuff, right? We need to get images. So in order to get those images, I'm going to tell you how to do that. So first, before I get into that though, let me just do some background stuff. So the image processing sequence generally follows, right? We have a statement of the problem, then we do some image data acquisition, then we do some pre-processing, image enhancement, extraction of information, so thematic or quantitative, and then you'll do some error assessment, change detection, geographic information system. If you need GIS, that's where you'll use it, and then you'll solve whatever the problem is, right? So that's all the background information that you have to do. That's all what I've talked about previously in all the other videos. So that's all image processing, which is just the core work. But once you have everything but all that, then you can work on the greater process. So you'll be doing in the field something that follows this kind of method. So you'll this is kind of like when you go into work and you're doing a full job. So this isn't just the image processing which you'll be doing all in ENVI. This is the full project itself for a client and all that. So you want to define the required information, and then you want to see if there is a matching product for what you're looking for, which sometimes there isn't, sometimes there is. So if no, then you want to select an optimal image dataset, a processing technique, and then the output, depending on whichever satellite or aeroplane or drone you're using like that. So if you can't get the image, then you have to acquire your own. And then you also want to define the required resources, so the image and spatial data you'll be working with, the hardware and software. You may not use ENVI, there might be some other program, but I don't know what those else would be. And then you'll also be looking at the time it takes you to do all this. And the client would have to compare the cost of image processing depending on if your company does it cheaper, or because you're working for a client, right? They want to see, they might be, say, like a fishery group or something. They might be maybe like a prawn company. Maybe they need to know where prawns are moving, where they're breeding, and all that type of stuff. So the client will decide. That's if you could see prawns through the water, which you might not be able to. But your client will decide if your company is worth going with. So now I want to talk about some considerations for getting the remotely sensed data. But just before I tell you how and where to actually get it, there's a few considerations. So you have to be mindful of course, the spatial, spectral, temporal, and all that. And so this boils down to a compositional look, so what's on the ground, a configurational, talking about the spatial distribution, the biophysical properties of what you're looking at, and any temporal variations. And in this table, you can see the general stuff you'll need to be concerned with. So this table looks at the extent of the area of interest you're working in, so the mapping units and the smallest feature that your pixels will need to see. You'll also need to consider the spectral and absorption characteristics of the feature that you're looking at. And then there is also a number of temporal concerns, like the timescales at which the environment changes. So by which I mean by that, the timescales would be so from a sapling to a plant. You need to know when that change is going to occur, because if you're doing an image scan and you have one in 1 year and one in another year, and you've missed that change of feature, if you miss a flower bloom from green to opening up to be red, then that's what you need to be concerned with. And you also need to be concerned with seasonal effects. So winter and summer can affect plants and all that. And you may want to create a spatial temporal plot as a guideline to the size and time scale of variations in the feature. And after all this, there are of course cost and time constraints by doing all this. And beyond all that though, I now want to tell you where and how to get data, image layers, and all that. But first, let me tell you what's good for what. So this first image shows which satellites are generally good at which scales in terms of the time and costs it'll take you to actually get useful stuff, without having to take multiple costly scans from a small satellite. So you can see that LandSat isn't technically the best if you're looking for such a large global area. So LandSat's like the second from the top. And then you have the second image, which will show you for which likely features you might be looking at in the field and how constantly you'll have to be looking at them. So water quality can generally be done at an 8-day visit for a site by a sensor looking at a 1 square kilometer area. Depending on the pixel size that you'll also be looking at. Okay, so now you've got some general information for land types and satellite types of different features of scale. So now where do I get my layers so I can actually do the calculations on them? So in order to do ENVI right, you need to know the actual, where do I actually get the maps so I can use ENVI? So depending on the sector whereby you're getting images from, you have a few choices. So there is government or private sector, right? So every single continent or country, or not every country, every continent should have this, a government level where you can get images from. So for Australia, you can get the Digital Earth Australia images, and you can see you can get details for each sensor available to Australia at www.ga.gov.au. And in the USA, you have Earth Explorer. And in terms of private groups where you can get images from, you have satellite options like Geo Image, and you also have Digital Globe. And I think Amazon and Google are doing something. It's 2 to 9 cents per gigabyte or something. And then you also have airborne options like Nearmap. And so that bottom right image there, that's Nearmap. So essentially what these are, they're just very high quality images. And what you're looking for is for images which can be broken up into individual bands, right? That's what you're trying to do. So you also have the option of Esri, but I think it's more GIS based, so that should be all features rather than pixels and rather than wavelengths and light. So if you're looking at Esri, that's probably more just GIS. And then I'll probably be doing GIS in a few months' time, not for an introductory course, but I'll be doing a more advanced course. If you want introductory information into GIS, just get the Getting to Know GIS textbook, and that'll take you through all the basic stuff. I think it's $100. And it'll take you how to use the program in entirety, but I don't really want to turn the entire textbook into a YouTube video because it'd take a bit too long, and I've already done this for ENVI, so I don't really want to do it twice. But anyway, when acquiring image data, and this can be purchasing or getting your own first, right? So in purchasing archived datasets, you have to be aware of the location within image data coordinate systems or flight line diagrams. So you need to know when you're purchasing archive data, you need to make sure that all your images, if you already have other images, make sure that they're the same coordinate system, and make sure they're you want everything to be the same that you're working with. You don't want to have to mix and match, do geometric corrections and all that. If you can probably not, that'd be the best. And this has all this type of stuff. If you're acquiring your own datasets or if you're purchasing datasets, you have the problem of copyrights and copyright restrictions. And I'll tell you a way to look at that. But anyway, in acquiring your own datasets, you also have to, it can be broken into 2 groups, sorry. So you have airborne in acquiring your own images. So you can, you have to first check the selected sensor type and provide coordinates. So you have to basically you're just telling the plane where to go. And if you're doing an on-site survey, you make sure that you do that on-site survey at the same time that the plane is going over. You want your data to be at the exact same point in time. Yeah, so if a plane is going over at Tuesday, so the company that takes the images called you, they say, well, hey, we're sending a drone over on Tuesday. So then you have to go to the site on Tuesday at that time and get on-site samples at that time as well, because you don't want to take samples at different time to when you got the images. Otherwise, you're going to have problems later down the line. And if you if you're acquiring your own datasets from satellite, or if you're purchasing it by satellite, be in mind of resolution concerns, so pixel qualities. And about that, legal concern stuff, which affects, no matter how you get data, you always have to be concerned with legal stuff. So if you just go to ucl.ac.uk, they have this link which will tell you about all the legal stuff to do with satellites and all that. So satellites have their own major problem when you're taking images and all that. You have to go through all that kind of stuff. Anyway, finally, we're in planning remote sensing projects. You want to make sure that you follow these three main categories. So you can just read that yourself. But basically, if you just look at the basic project planning sequence, the second group, you're basically just establishing a project resource constraints, and then you want to define your project phases and budget and set the task schedule. So you're doing all this for your employer. Then you want to check the schedule, the budget, and the product against user specifications. So remember, the employer wants all this stuff for the client that you'll be working with. So if I had to sum up the entire process, it would be something like, make sure you have enough money to secure the images required, whether you do this from scratch or are lucky enough to get pre-made images at the exact quality you want for the exact area. Make sure you have enough time and space to enough time to space out your process to do everything that I've said. This goes across all the videos up until this point. And make sure your probably dumbass client doesn't go back on what he said, like, yeah, no, I've changed my mind. I want an image at a different time or something. And finally, reflect on the process so that you realize that this field is easy, but God, is it also needlessly difficult. And so this brings us to the final product. So finally, in completion and in communicating your spatial data, just be aware of various cartographic standards. Geez, I should be able to say that. So you have your scale, legend, north point, author, copyright, projection, datum, and all that, everything else that you might need to have. And in your metadata, you need to have the type of sensor, the date of image acquisition, the orbit, if you have a satellite, the geometric accuracy, the band combination, and processing details and any kind of history. So anything to do with your map layers, make sure to put everything in the metadata if you're acquiring the images yourself. Otherwise, the company where you get the images from should all have that all finished for you. Anyway, so that is the process to do all of this. Now that you've figured out how to actually work in ENVI, this video hopefully has showed you how to get your images and how to work with your boss to produce some images to analyze your images for a client. Anyway, I hope you guys have learned something and have a great time.